Okay. Welcome to the Flux Bug Scrub number, I think, what is this, 24 now. This is a special edition of the Flux Bug Scrub. Our first guest presenter, I'd like to introduce Antonio.
Yes, welcome everybody. I'm Antonio. I'm an ET ops specialist. I work in EcoMind, an Italian society. We work in specifically in cloud environments. Our products are cloud native, and we work in the AR world. We make a software which allows technicians on the field to be in contact with the ones on the support, on remote support, allowing them to be supported by more skilled people where they are on the field. And we do also another software for a big Italian company about digital document signing for archiving documents digitally signed. GoSign is our products are GoSign, and i4Task is the main one we do. The one which I do most of my work.
Awesome. So can you tell us a little bit about what we're going to see today?
Yes, I realized it just for fun initially. Now I'm going to deploy this in one of our development setups for our developers. And it consists in a complete cluster, Kubernetes cluster managed by Flux, which interacts with a local, completely local Git server. So everything is completely disconnected from internet. They can test our products completely offline on their machines, simulating what we do daily on daily basis with our production systems. So they can simulate locally what Flux can do to reconcile new resources and whatever Flux does, exactly as we do in our deployed clusters on AWS, Azure, and Google Cloud.
So, okay, so we're starting with
yes,
absolutely nothing on a Docker enabled.
Yes. There's absolutely nothing running here. I tried to open a K9s, which is just a as you see, it's seeing some clusters, but not the one I had other clusters on my machines, but not the one we are going to deploy, which will be called test glue. I have other stuff on my machine which runs on its own, but it's not what we are going. We are going to deploy a new cluster from zero, completely from zero. So this I splitted my screen in various sections. Here in top left, I'll show the script while it's running, so we can explain something. Under that, there will be the script running. Here we will see the repository where the manifests created and deployed to the cluster will be added while they are deployed to the cluster. And on the right, we will have two windows with the K9s to monitor in a more interactive way what will be going on the cluster. So I created the script with an option with a switch -d, which which allows you to have an interactive way to interact with the script. If you does not give this switch this option, the script is completely and fully unattended. So it will deploy the cluster, will deploy the Git repository, will deploy a demo app, which is Prodance Podinfo, and completely from start to finish in about 2 or 3 minutes. We're going in the interactive way today to just to have to have the time to explain what's going on. So, okay, the first thing, everything will be created under this folder on your machine. So test git. This will be the test repository, which will be which will where we will deploy our we will push our we will create our manifest, which will be then pushed to the Git repository. This will be our cluster. This will be our DNS name, where our services and will be available on different ports. We will see soon. Other than that, the script will just start adding some stuff to your etc os file in case you don't have it. So this DNS name and your local LAN IP address will be added automatically to your etc os, so they can be resolved by your system. Other than this, it will generate, as you have seen below, a couple of private and public keys that will be used both by the cluster to access the Git repository and by ourselves to push files to the Git repository. So starting from now, as you have seen in this folder, was just created the bare minimal Git repo with just a README. Now we are going to deploy the cluster. I'm using k3d to deploy the cluster, which is a solution by which uses k3s as its engine, which is approved by Ranger. This allows to create a complete cluster with single or multi-node setups on your machine. Okay. I've opened two I opened two windows with the K9s to monitor what's going on. The script is now, let me go forward. Okay. The script is now at this stage. Okay, clone deployed. Okay, waiting for the config map. Okay. Core DNS, the DNS in the cluster, needs to know about the domain name we defined above. So needs to know about the DNS name we set at the beginning of the script. So we are now waiting for the cluster to deploy its components, and we are going to patch the core DNS, adding the IP address, my local LAN IP address of my machine, and the DNS record we added above. So we are going to patch this. As you can see here, it was created a new config map, which is which adds that domain name and that IP address. So now the cluster can knows how to access my external machine where the Git server resides. After this, CoreDNS was killed and recreated, so it could read this new custom config map with the new record. Now we are going to create the local Git server. Okay, I'm using this. Oh, sorry, was at the beginning. Okay, I'm using this Docker image. I just found that was the more appropriate for my needs. It has all I need to have a complete, a fully working local Git server. So it going forward. Okay, so we deployed the Docker image for the Git repository. It's running in my Docker. It's external. Well, it's completely external to the cluster, so it's completely separated from it. I waited for its port to be opened, and then I added my SSH keys to it, so I can now connect to it. As you see. Here it tried to connect to the server. There's no full SSH server in this Docker image. It just reported back that the connection was successful, and there's the server is up and running. Now we are going to do the Flux bootstrap. So here soon we will see a bunch of manifests as soon they are deployed. On the top right, we can see that Flux is being deployed in the cluster. It's about to go online. Now we are waiting for the customization. Okay. So Flux is completely fully deployed in the cluster now. And now we are going to add the CoreDNS config map we created above, just for the sake of it, to have even that in our repositories. So the repository will be full with all it's needed to recreate this setup. Now we are going to clone the Git repo and add some resources. Okay. As you can see, I've so the bootstrap phase added the Flux components to the cluster, pushing them to the Git repository we created above. Now we cloned back from the Git repository to our local folder, which is just a Git clone of that repository, and we have just the CoreDNS custom, which I already said before, and the Flux components. There's nothing more other than this. This is now a local cluster with the Flux working on a local folder. Now I'm going to deploy the podinfo Git repository, basic components. Git repo. Basic components of Flux are the source controller and the customized controller. The source controller is the one that fetches the artifacts from remote Git repositories and allows the customized controller to apply them to the cluster. So now we have we now have just the Git repository where the cluster can go to fetch the podinfo manifests. Now we are going to add the new customization, which applies this to the cluster. As you can see, here we have two new resources. the pod info source was the one of before, and the pod info customization is the one which is creating a deployment with the I think a couple of replicas of pod info app, and soon we will have okay, soon we should see pop up, ecco qua. Okay, so the script opened the port forward towards the deployment. So this is the domain we talked about before. On port 9898 was created the port forward exposing the pod info deployment. Going back here. So now, before going on and modify the pod info deployment in the correct way, in the GitOps way, I'm going to try to edit this deployment and change its color to a different one. If I try, here it is. We will see that after a while, okay. Oops, sorry, I missed. Okay.
This is a pod, not the actual deployment, I think.
Oh, right. Sorry. You're right. Okay, it's recreating the pod. Now I need to get rid of the. I don't want to break the script which will kill the port forward going on. But to show you how to show you if I modify something in the cluster which is not pushed in the Git repository, this will be wiped by the Flux customization as soon as it's reconciled. I leave this port forward here and I'll kill from here. Okay. Okay, and this is it. No, this is it. Okay. And I'm going to open a new port forward. Now, if I go to my browser and refresh, okay. As you see, the background changed because I changed in the deployment. But if I go here and force a reconcile of the pod info customization, reconcile, it will see that the desired state of my cluster and the one which is now deployed is different, and will soon kill the pod info deployment and create back, will revert the modifications I did on the deployment, bringing back the original color.
So that's the Git repository there, right?
Yes, yep. Sorry,
right.
sorry. Okay, I'm reconciling the, okay. I'm reconciling the customization, sorry, I was in the wrong window. As you see above, it's killing some pods and it's recreating them, and I'll kill the port forward and reopen, and we will see as soon as it's complete that the color changed back to the original one. Okay, here I'm using some plugins I added to K9s to allow reconcile of Flux resources and toggle them so to suspend or resume a customization, a Git repo, an Helm release, whatever, directly from inside the K9s are some plugins I made a while ago. I reopened the port forward, and we should see back. Okay, it's back to its original color because we modified the resources direct in the cluster, not via Git repository in the GitOps way. Now we can now going on with the script. So here, as you can see, was created. Let's see the script again. Let's see the script. We are going now to patch the deployment using a customized patch. So this is okay. As you can see, it's worked, and now they were opened two windows. We have here the DNS name with the port 9898. So this is the new port forward which was created for after the customization applied the patch to the podinfo deployment. And here we have the port 8081, which is instead the an ingress. I added an ingress to the script, so this is the correct way. This is the correct way to point a resource, a service in our cluster, which will survive the port forward. The port forward can be killed. The service remains active while the even if the pods will change in the background. Let's get back to the script. Okay, so it was created a patch, and if I go here, YAML, okay, as you can see, it added it changed the color, and we can see here Flux system customization. We can see here, this is what was added by the customization patch, addressing the specific deployment podinfo and all the spec I needed to reach the color in the podinfo pods. Other than this, I now press enter. This stopped the podinfo port forward, but left opened the service. So if I refresh the 8081 port, which is the service, it's still alive. While if I go to the podinfo port forward, it's dead. So I think I showed everything. Other than this, you can run these 4 lines to get completely wipe what we did. So it will stop the Docker Git server, remove it from Docker. It will kill the cluster we created with k3d, and will wipe all the folder containing everything we did. So this will restore your machine to its previous state. As you can see, we have a completely functional cluster, Kubernetes cluster, connected with the completely functional Git repository on our local machine, and we deployed the test application using GitOps. I think I finished.
Awesome. Thank you very much.
Thank you. Thank you.
I have a few questions, but I'll let anyone else go first who wants to go first.
I'll stop. I'll share. I'll continue sharing the screen in case someone asks something.
So my first question is about the core DNS patch. Now I know why you did this because we developed this together, but I
Yes.
want to make sure that it's clear for everyone who's watching exactly what's happening here. So
Yes.
inside of the cluster, we
Yes.
want Flux to be able to reach this
Ec-
SSH server that's running the Git
Yes.
server.
Yes. Yes.
So that needs to happen with a manual patch to core DNS before Flux is deployed.
Yes.
But then once Flux is deployed, we'd really like for all of our config to be in Git.
Yes. And I just added it to our Git repo. Oh, I can show you this. Wait a second. This is Git Kraken is just a GUI to Git. This is our Git repository. So this is just when we deployed the Git server and the bare minimal Git repo, we just added a README MD file. Other than that, we bootstrapped Flux in the develop branch. So this is another branch, and after that, it added its manifest. After that, I added this just because I want in my cluster everything I want in my Git repo, the one which is monitored by Flux, all my resources. So in case I have to restart from scratch in a new cluster, I can re-add all my resources and get back to my previous state. Of course, besides the physical volumes, and we are not using them here, but we need a way to back up the data in our persistent volumes in other ways. We are just saving all our services and manifest configuration, our desired state of our cluster. The data is beyond this setup, of course. And so I just added this to have even that in my Git repository, and in case I want to redeploy this on a new cluster, I can just point Flux to this Git repository. Instead of doing the full bootstrap, I can just add its core components. I can add a Git repo pointing to this Git repository, and I can add the customization which points to the folder in which are all my files, and I can bring back my cluster on a brand new one, which will be exactly the same of the one we saw today.
So if this wasn't a local development server, there would be no need
Yes.
for that core DNS patch. But because we need to make sure that Flux can actually reach it at an address,
Absolutely,
for
yes.
various reasons, like SSH host key matching and all those other
Yes.
things.
Yes.
That
Yes.
stuff all happens here. Cool.
Yes. The core DNS just adds the core DNS config map patch just adds a new domain and the new host pointing to my machine. The name I chose for the IP address of my machine. Nothing more than that.
And core DNS knows about this config map name. So if you just put it,
if you remember when we worked on the script, initially I was going to create this record directly in the YAML of core DNS. After that, I have found that you can push a manifest, a new config map called in this way, core DNS custom, which allows you to add patches to core DNS in the correct way, without touching the original manifest of core DNS. Core DNS in recent editions, if it finds a config map named as such, it will apply it, and you need to kill it and you, in our setup I had to kill it, and so it could reread this config map. In normal setups, this coordinates patch will be applied sooner to the cluster. So when coordinates brings up, goes up, it will finds it and applies automatically.
You would do it like through a kubedm config or something, so it's there when the cluster first starts before coordinates.
Yes, okay. Yes. I didn't want to have to interact with the way k3d creates the cluster. If I use the k3d or other ways of creating a cluster, I probably I could do this before coordinates goes up. I wanted to k3d to do its stuff completely automated without interact with it. It's just the k3d part is just a simple k3d cluster create and the name. I just added the load balancer port in recent modifications to the script to add the ingress. You pointed me to add this in our previous chats, so I added this too. But other than this, if you just want a cluster with k3d, you can just run this command k3d cluster create and the name of the cluster. So I didn't want to add more stuff and more parameters to the create phase to interact with CoreDNS, so I made in the other way, adding the patch and simply killing the pod, and the cluster recreated it in the correct way.
So this is a low-touch integration with k3d. It doesn't
Yes.
really matter that it's k3d. We're not leaning
Yes.
heavily on
Yes,
features of k3d.
Yes, this is specific to k3d. Probably you use Ranger. You did differently this part. Ranger desktop.
Yeah, then I also love the part where you showed how the ingress works better, and how I'm not sure if everyone would understand, but probably most people who would find this video would already understand how port forward works. That there is really, you can point it at a service or you can point it at a deployment, but it's just going to pick a single pod and forward
exactly
to that pod. So when that pod dies, the port forward dies. That's why
exactly
you saw a few places in the demo where we get disconnected and we have to start a new port forward, and that's
exactly.
Cool.
I added the part where I modified the color of the background of which was deployed by the podinfo app, just to show how how Flux preserves the desired state. So if you don't push something in the Git repo monitored by it, it will revert your modifications and will bring back your setup to the previous and the desired state.
So we have another question from Lorenzo in the chat about how we can include more dynamic source information, like that external IP. Let's say our IP address changes.
This is a
difficult question.
This is a function which tries every local network interface until it finds the one that responds to the ping, and to find it, it just cycles between all of them until it finds the correct one. It just a script we found online and added to this. Before of this, you had in the config part. Before all this, in the early revisions of the script, if you remember, there was another couple of parameters up here where you had to manually add the local IP address of your machine here. Now this is completely automated. It will be retrieved by your system and added to the coordinates patch and to your etc hosts. You need that line to be in your etc hosts too. Otherwise, you need it in the coordinates, so it knows how to reach the Git repository on our machine. You need to add it to your etc hosts file, because otherwise, when you go to open this URL, it does not work. It does not have nothing to point. So we just to have, as I used the same SSH private and public key for everything in my setup, I just wanted to use the same domain name for everything. So for the services, for a way for me to reach the services exposed by the cluster, and for the cluster to reach the external Git server. So it just to have a single thing for everything.
So I think the answer is, if you updated the config map in place with the new address and you updated your etc hosts in place, it would probably be okay. But I'm skeptical that k3d itself would react well to having its control plane address changed out from under it. So maybe
probably
maybe that would work, or maybe it would not work. I think
probably a restart of the cluster could be needed, and I didn't try this.
Cool. Yeah, Lorenzo's got his hand up. Do you want to open your mic and ask a question?
No, yes, thank you. I'm okay with your explanation of the expected behavior with k3d and the Git repo. In fact, if we have all the state in a volume external to the Git container, and so what we can do is to, when we switch the IP address, is just to take down the whole k3d cluster and the Git repo too, and restart everything by pointing at the same Git repo on our local storage.
Yes,
that
because
Flux will repopulate the whole cluster, the whole k3d cluster entirely by what it can see from the Git repo. So yes, that's the power of GitOps in a sense. So that will be the better way, instead of trying to populate as I said, a dynamic source for the customization, restarting the whole thing, having the single source of truth in the Git repo would be perhaps better. I understood correctly? Did I understood correctly?
Yes, absolutely. I think we agree on that. We agree on that daily basis. So
I think this was an extremely effective demo. Thank you.
GitOps is the way. Thank you to you.
Any more questions before we stop the recording? Okay. All right. Thanks, everyone.